Hey everyone, today we are looking at something different. Next to me I have the Prusa Core 1L, which was sent to me free of charge by Prusa, but this is not a review. Instead, I want to take you under the hood and give you a genuine insight into the engineering behind the success of Prusa 3D printers. Here with Voxel 3D. We often focus on the Prusa name, but we forget the research part that is still there. This is not just a company purely structured to make money. Prusa is more of an R&D team with a business share around it. While other brands might chase every trend the market shouts for, Prusa tends to take its time and build a printer its research proves the customer actually needs. Today I'm going to pull back the curtain on some of the engineering that makes the Core 1L tick. Not to tell you how fast it can print a Banshee, but to explain why their machines outlast almost every other 3D printer currently on the market by a margin. Let's dive into it. Let's start with the motion system. In mechanical engineering, every connection you make is a trade-off. To keep a part moving perfectly on a line, you need exactly the right constraints. Add one too many and you have over-constrained the system. It's a fancy way of saying your machine is essentially fighting itself, which can lead to binding, friction and eventually part failure. Think about a train track. You have two rails but one set of wheels. If those train rails are perfectly parallel, the whole system moves smoothly, but the second one cross beam is shorter than the other, the rails start pulling in a different direction. The wheels don't just roll anymore, but they grind, they wear and they scream. Now look at those train rails as the Y motion rods in a 3D printer. If they are perfectly aligned, the x-axis just flies. But if they are even slightly off, your bearings will chew themselves up, your motors will struggle and your hardware hits an early grave. But here's the catch. Perfect does not exist in a factory. Every part has tolerances, tiny but unavoidable errors of sometimes just fractions of a millimeter. If you are building a machine out of dozens of separate pieces, those errors can stack up until perfect alignment becomes statistically impossible. So let's take a look at how Prusa designed their XY motion system on the Core 1L. Usually you'd see the two eye rods mounted to the frame, with 5 or maybe even 6 different brackets or connections holding them in parallel. On the Core 1L, however, every critical component is mounted onto a single massive machine-made part. Not because this improves profit margins, but because one part means one set of tolerances. You are not stacking errors from 5 different parts like a game of engineering Jenga, but Prusa makes sure the problem is solved by the way the parts are engineered. As Dominic from Prusa 3D says,
it's not an easy task to build a Core XY gantry or the motion system so it is perfectly aligned and everything sits together and you don't have to tweak it later. So the R&D department decided that they would go with one single piece. So when the customer gets it, he just installs the parts for the Core XY, and he doesn't have to tweak the 90 degrees angles or stuff like that.
Another example of this clever engineering can be seen with a Z motion. From factory, lead screws will rarely be 100% straight. If you mount them rigidly onto the bed, they will force that bed to move horizontally with them as they turn. However, the Core 1L purposely leaves them unconstrained in the XY plane, only locking down the Z-axis. By letting them float instead of fighting the rods, they eliminate the wobbles and artifacts that can plague cheaper or over-constrained machines. Instead of forcing the user to calibrate or accepting high wear, they actively embrace the reality of manufacturing to ensure it works by design. They have even accounted for the invisible physics, like material science. The steel x-axis, for example, might seem counterintuitive. I mean, aluminium is lighter and lighter is faster, right? Sure, maybe, but an aluminium x-axis would expand at a different rate than the steel THK rail, which could bend the entire assembly and cause extra stress. It is that level of boring engineering that you don't see that ensures your 1000 hours of printing looks just as good as your first. Now, speaking of thermal expansion, there's also something I want to show you with the heated bed. On the Core 1L, it consists of a 300 by 300 mm solid slab of aluminium. When this aluminium gets hot, it grows, physically expanding by up to 0.7 mm. If you bolt it down tight, the only place for that extra material is to go up or down, causing the bed to bow. This is always visible on the first layer of cheaper machines, and it's one of the main reasons mesh bed leveling is required on almost every 3D printer today. But now, if we look at the Core 1L, we see that Prusa used a 3-point mounting system. To accommodate for the 0.7 mm of growth, they use expansion joints with centered constraints. This allows the bed to expand freely outwards from the center, but always equally in all directions, so it stays perfectly in the middle and perfectly flat without bulging. Again, they are fixing the issue in the design, rather than relying on the user or the machine to calibrate all the issues away. Now, one of the most famous rules of engineering is keep it simple, stupid. It sounds blunt, but it's actually a vital aspect of good design. You can see this logic in how they handled the vents on the Core 1L. In most machines, the instinct is to solve a problem by adding a feature. For example, if the chamber gets too hot, you add motorized shutters. However, every part you add is another potential failure point. A motorized vent needs a motor to turn it, a sensor to trigger it, and code to tell it what to do. If any of those three fails, the problem still remains. So, instead of building a smarter vent, the Core 1L engineers relied on a simple piece of plastic to control the state of the top vent. They have optimized internal airflow and geometry, so the existing parts of the machine do the work that extra components do on other machines. It's a Zen type of approach to design. If you don't need it, just don't build it. By stripping down the machine to its essential geometry, they are not just making it simpler. They are making it nearly impossible to break. The best part is no part. It costs nothing to make, it can't break, and it needs no servicing ever. At the end of the day, Prusa is not just selling a 3D printer. They are selling the engineering hours that went into making a solution they know will last. From a 3-point bed mount with concentric expansion joints to the single machined XY motion plate, every choice is made to prevent failure at the root cause. Now, I've tried to answer the biggest technical questions today, but I know you probably have more. If there's something specific about the Core 1L or Prusa's engineering you're curious about, drop a comment below and I'll try to follow up. Thank you for watching. If you're curious about what I normally do, feel free to take a look at Inbox, a system I have designed for index on Core 1L to save space and to keep your spools in perfect shape. The link is in the description, and I'll see you on the next one.